Good morning, everyone. I'm Lohith.S from the Department of CSE, first year. Today, I'll be presenting a detailed explanation of hydraulics and water resources engineering. This presentation covers hydraulic engineering and hydraulic structures, hydrology, irrigation, water supply, and sustainable water management. To begin a short, strong foundation, let us first understand the hydraulics, what actually it is. Now let's move on to the introduction of hydraulics. Hydraulics is the study of fluids and their behavior under different conditions. It includes the study of fluid motion, which helps us understand how water flows in nature and in man-made systems. Hydraulics is widely used in engineering systems such as canals, pipelines, dams, and water distribution networks. To understand it better, let us now look at the formal definition of hydraulics. This deals with liquids, focuses on forces. Hydraulics mainly deals with the liquids, especially water. It focuses on the forces acting on fluids and how those forces affect fluid movement. Engineers study how liquids behave under different pressures to design safe hydraulic structures. After understanding the definition, let's explore why hydraulics is so important in engineering. Now let us go to the importance of hydraulics. Hydraulics is essential because it is used in almost every water related structure. It helps design dams where enormous water pressure must be safely resisted. Hydraulic principles are used in canals to ensure smooth and controlled flow for irrigation. Pipelines for drinking water supply and drainage systems also depend heavily on hydraulics. To study hydraulics, we must know basic fluid properties. So let's move on to the fluid properties. The fluid properties from the foundation of hydraulic analysis. Density tells us how the heavy the fluid is per unit volume. Density tells us how heavy the fluid is per unit volume. Of course, viscosity determines how easily or slowly a fluid flows. Surface tension explains how fluid molecules behave at the surface, especially in narrow channels. Having understood fluid properties, now let us move to the fluid statistics. Fluid statistics deals with the liquids and that are not moving. Pressure at restrict areas and rest increases with depth and affects structures like dams and tanks. Pascal's law states that pressure applied at one point in a fluid is transmitted equally in all directions. Hydrostatic force helps determine the load and acting on submerged surfaces such as gates and walls. Now that we know static fluids, let us understand fluids in motion through fluid dynamics. Fluid dynamics focuses on fluids in motion. Different types of flow, laminar, turbulent, uniform, and non-uniform, play a major role in design. The energy equation explains how energy is transferred within and explains how energy is transferred within the flowing water. The continuity equation ensures that the amount of water entering a system equals the amount leaving it. Next, let us look at the hydraulic machines which use these principles. Hydraulic machines convert fluid energy into mechanical work. Pumps add energy to water and move it through pipelines. Turbines extract energy from flowing water and are used in hydroelectric power stations. Hydraulic pressures use high fluid pressure to perform heavy industrial tasks. After machines, let us understand how we measure water flow. Flow measurement devices helps determine the flow rate of water. A venturi meter uses pressure differences to calculate discharge. An orifice meter measures flow through a sharp-edged meter and sharp-edged opening. A pitot tube measures velocity by comparing stagnation and static pressure. Once we know how to measure flow, we can study open channel flow out. And the next topic is open channel flow. Open channel flow occurs when water flows a free surface, like with the free surface, like in rivers or canals. Uniform flow means depth, slope, and velocity remain constant. Critical flow represents the balance between gravitational and interior forces. Manning's equation helps calculate velocity based on slope, roughness, and channel shape. Now that we understand hydraulic concepts, let us see their applications. Coming to the applications of hydraulics, hydraulics is used in irrigation systems to deliver water efficiently to fields. It is essential for designing water distribution networks in cities and industries. Hydraulic structures like dams, barrages, and spillways rely heavily on hydraulic analysis. Now, with the hydraulics covered, let us move to the water resources engineering. Water resources engineering focuses on managing water for various human and environmental needs. It ensures continuous water supply for drinking, agriculture, and industries. Effective water management supports economic development and improves living standards. Next, let us explore why water resources is important. Water resources helps prevent floods by planning drainage systems and regulating river flow. It ensures sustainability by balancing water use and conservation. It improves water usage efficiency through modern designs and management practices. To manage water, we must first understand hydrology, which is our next topic. Hydrology basics. Hydrology studies the movement and distribution of water on Earth. Rainfall study helps determine how much rainfall an area receives. Runoff estimation tells us how much water flows on the surface after rain. Infiltration analysis helps us understand how much water enters the soil to recharge groundwater. After hydrology, let us move to the surface water resources. Surface water resources includes rivers which carry flowing water naturally across regions. Lakes hold water naturally and serve as major freshwater sources. Reservoirs are artificial water bodies created by we humans, dams for storage and supply. Now, let us discuss groundwater resources. Groundwater is stored in aquifers, layers of rock and soil that hold water. As I have mentioned in image, wells are constructed to extract groundwater for drinking and irrigation. Recharge methods like recharge pits and percolation tanks help restore groundwater naturally. Now, let us continue with irrigation engineering. Irrigation engineering ensures controlled water supply to crops. Canal systems distribute water across large agricultural fields. Sprinkler irrigation sprays water uniformly like natural rainfall. Drip irrigation supplies water directly to plant roots, reducing wastages like many farmers used in these days. Next, we'll move to water supply engineering. Water supply engineering ensures safe drinking water for population. Treatment processes remove impurities and make water safe for us. As nowadays we'll see that they are adding chlorine in water to purify the water more consistently. Distribution networks transport treated water through pipelines and storage tanks. Quality control ensures that the water meets healthy and safety standards. Now let us understand how water quality is monitored. The water quality is monitored and managed, evaluates whether water is safe and pollution free or not. Physical tests check properties like color and turbidity. Chemical tests measure pH and hardness and presence of harmful chemicals. Biological tests identify microorganisms present in water. Next, we'll move to the sustainable water management. The sustainable water management ensures long-term availability of water resources. Reuse involves using treated wastewater for irrigation or industrial purposes. Recycling further purifies water for more advanced uses. Conservation focuses on reducing wastage and promoting responsible water usage. Finally, let us look at the challenges faced in water resources. The challenges that are faced in water resources are climate change causes irregular rainfall, droughts, and floods. Population growth increases the demand for drinking water, irrigation, and industries. Urbanization leads to water pollution and over extraction of groundwater. With this understanding, let us conclude the presentation. Thank you. To conclude in conclusion, hydraulics helps us understand fluid behavior and design efficient water systems, while the water resources engineering and helps us the water resources engineers also helps us to manage water sustainability. Both fields are essential for solving modern challenges related to water supply, irrigation, hydropower, and environmental protection. Thank you for listening to my presentation.